Okay, number 5, find the reference angle. This time we're given an approximate, as exact as it can be, radian measure in decimals. So you may have done this a little bit last year with decimals. You may not have, but we're doing it now. So negative 4.3633 radian measure. So on your calculator, you need to make sure that you are in radian mode. On your scientific, you have a DRG button somewhere. You can turn it into radian. On your graphing calculator, you need to be in radians. Mine right now is on degrees, so I'm going to go down a couple rows till it's blinking on radian and hit enter. And so now I'm in radian mode on my calculator. I think you don't actually need to do that because you're just going to be working with pi and adding and subtracting. But in pre-calculus, it's good to have your calculator in radian mode anyway. So what I want to do is figure out where the angles I'm used to working with, the exact values, specifically the quadrantal angles, like 0, pi over 2, and pi, where those are in decimal form. So on my calculator, doesn't matter what mode you're in, but I need to figure out, I know pi is 3.14, so pi divided by 2 is 1.57, and 3 pi divided by 2 is 4.71. So we also know pi, right, 3.14. So we're going to use those numbers on our graph to help us out. 1.57 is pi over 2. Now I have a negative value, which means I'm going to be going negative around going to be going clockwise around the graph. So negative 1.57 radians is going to be right on the bottom where 3 pi over 2 normally is. Negative 3.14 radians is going to be right across that pi because we start at 0. So that's negative pi. We said that negative 3 pi over 2 was going to be 4.71. So negative 4.71. And so now I know the ranges for my values, and I can plot this angle. Negative 4.36 is what I want. So it's going to start at 0, go clockwise, and end up somewhere in quadrant 2. Okay, that's between negative 3.1 and negative 4.7. And so then I want to find the reference angle. Reference angle is always drawn from a point on that angle straight down to the x-axis. Call this angle that's formed theta prime. It's called a reference angle because it refers to an angle in quadrant 1 that has the same trigonometric values for it as it does. So to figure that out, we need to find that difference there. So 4.3633, and I have a 3.14. So if I do negative 3.14 minus a negative 4.3633, I can get that value. So negative 3.14, wrong button on the point, negative 3.14 minus a negative, what did we say the angle was? 4.3633. That gives me a positive 1.2233. And that's my reference angle. Now, how did I know whether to do negative 3.14 minus negative 4.3 or the other way around? Well, I thought about it. I need a positive angle measure. So if I take the pink angle, negative 4.3, and I subtract the negative 3.14, I'm still going to have a negative angle measure. I'm just trying to find the difference between the two numbers, and I need it to be a positive difference. It doesn't really matter which order you do it in, as long as you realize that the answer should be positive. So 1.2233 is the radian measure. So again, if I took the sine of 1.2233 in my calculator, so sine 1.2233, that's a sine of 1.2233 radians, I get 0.94. If I take the sine of negative 4.3633, I should get the exact same decimal value. And I didn't type that in right. So let's try that again. Sine of negative 4.3633. Okay. Now, it looks close. We have 0.939 versus 0.94. And if you think about it, the reason that that makes sense is right here we wrote down negative 3.14. We only went to 2 decimal places. The answer given was in 4 decimal places. So if we would have gone to 4 decimal places, that would have worked out all the way.